Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 47 from the Smith Organic Chemistry textbook. And this problem asks us to draw a stepwise mechanism for the reduction of epoxide A to alcohol B using lithium aluminum hydride. And then we're also asked what product would be formed if lithium aluminum deuteride were used as a reagent. And we're asked to indicate the stereochemistry of all stereogenic centers in the product using wedges and dashes. Okay, and so the entire point of this problem is to hammer home the idea that lithium aluminum hydride does not deliver a hydrogen to the oxygen in this situation. And that holds true for the reduction of ketones and aldehydes as well. So it delivers a hydride to a carbon, never to an oxygen. And so with that in mind, here's the stepwise mechanism. It is fortunately a very short mechanism, so that's always pleasant. But so the hydride will be delivered to this carbon. And now in terms of stereochemistry, since the epoxide is on dashes and so is facing away from us, the hydride is going to be delivered on our side of this molecule. So it's going to end up on a wedge. And so you don't necessarily need to indicate the stereochemistry there because it's not a stereogenic center anymore now that it has two hydrogens on it. There's no chirality there. Remember, a requirement of chirality is 4 different bonds. But we can indicate it here, just to do it. So there's the hydride that we just delivered. And so here on a dash is the alkoxide that now results from that hydride delivery. So this oxygen has a negative charge, 3 lone pairs. It would like to make another bond. And so here is where the water workup comes in. So whenever we use lithium aluminum hydride, we always tend to finish with a water workup. And this is the reason why. So this oxygen, one of the lone pairs, can grab one of these hydrogens. And so now we've protonated our alkoxide and we have a neutral molecule. And indeed, this is the final product that we were asked to draw the mechanism for. So here's our final product. It's the methyl group. Put this hydrogen in here again just for consistency. And now we have our alcohol there. So that's part A. As I said, this is a very simple, straightforward mechanism. And so if we were going to use lithium aluminum deuteride instead, so part B here, the product would be exactly the same, except where we delivered that hydride, we would deliver, I guess it would be called a deuteride. So where we delivered that hydride, we would instead have deuterium there. And so nothing else about the molecule changes. Our final product is the same. The stereochemistries are the same. But here we now have a deuterium. And so again, the whole point here is to just hammer home the idea that lithium aluminum hydride delivers its hydride never to the oxygen, always to a carbon that is bound to the oxygen, whether it's the reduction of an epoxide, like this reaction, or the reduction of an aldehyde or ketone. It always works that way. And so that's the answer to Chapter 12, problem number 47.